Okay. So a lot of you guys already know me, but for those of you who don't, I'm Isaac. I've been a NARG member for just about 3 years now, and I'm currently in my second year as an undergraduate student over at the South Dakota School of Mines and Technology, which is in Rapid City out in South Dakota. And I currently work there at the Paleontology Research Lab on campus. I am one of the student workers as a fossil preparator. And this past summer, I had the wonderful opportunity to be able to work at just an incredible place called Ashfall Fossil Beds. Now, Ashfall Fossil Beds is kind of out in the middle of nowhere, Nebraska, and I had never heard of it before my boss, the lab manager at South Dakota, told me, Isaac, you have to apply to Ashfall for their internship. And when I started to learn more about the place, I was just blown away. I think Ashfall might be the most incredible paleontological site in the country. And so I wanted to share with you guys about that. And so without more further ado, let's get into an overview of Ashfall fossil beds. So in this presentation, I want to go over what Ashfall is, how it formed, the history of the site itself, the fauna that's present there, and the current importance of Ashfall in the field of paleontology, as well as what it was like for me to work there. So just a quick introduction to Ashfall. Ashfall is this incredibly rich deposit of super complete, highly well-preserved fossils, mostly of mammals, that are preserved in volcanic ash. And it's at the site of a seasonal waterhole in the Miocene. So 12 million years ago, there would have been this large depression in the landscape. And during the rainy season, it would fill up with water. And during the dry season, it would dry out. And this is an artist's rendition of the waterhole. So at this time, this area in Nebraska was a subtropical savanna. So the climate and the fauna would be actually remarkably similar to what you would expect to see today in the East African savannas. And we'll talk about that a bit more later. It's located in Antelope County, which is in northeastern Nebraska, and it was established as a state park back in 1991. So before we get too far into anything, the first question we want to look at is if all of these animals at Ashfall are preserved in volcanic ash, where did that ash come from? So that would be the result of something that's called the Bruno-Jar Bridge event. So 11.8 million years ago, the Yellowstone hotspot produced a supervolcanic eruption in southwest Idaho. So a lot of you guys are probably familiar, there's a large volcanic hotspot deep under the crust where Yellowstone is. And every so once in a while, it produces an enormous volcanic eruption, thousands of times larger than the Mount St. Helens eruption. And while that hotspot stays planted deep under the crust, the continent is actually moving over it. So in the past, different parts of the continent have been over top of that hotspot when it erupted. So 12 million years ago, this white circle here, that's the Bruno-Jar Bridge caldera, was where Yellowstone is now today. And so when this eruption happened, it kicked ash all over the continent. You can see sort of the spread on the map there. And we found the deposits of it in a number of places. Each one of those white triangles represents a deposit of the ash from this eruption. And we can see that we found it in Nebraska, in Idaho, Nevada, and in California. And we've actually even found this same ash in cores in the Atlantic Ocean. So that tells us that the ash went so far east that it went to and even past the coast. However, even though we have all of these different deposits of the ash, we only find fossils at Ashfall itself, which is up there in the northeast Nebraska.
I want to monitor the chat. Sorry.
So the reason that we only find fossils in the one spot is because of that water hole there. So when this eruption happened, the entire landscape around Ashfall was covered in about a foot of ash. And the animals would have been inhaling that ash, it was damaging their lungs, and they were eventually dying from that. But for most of those animals, that single foot of ash is not enough to bury their bodies and to preserve them. However, for the animals that died actually in the waterhole, in that depression, the wind would then sweep that ash into the waterhole, slowly filling up that depression, covering their bodies, which is what allowed them to be preserved. So as far as the geology of Ashfall, all of Ashfall is part of the Ash Hollow Formation. But within that formation, there are three sort of distinct layers that we talk about at the paleontological site. So at the bottom, we have what we call the waterhole or yellow sand. That's a sandstone that's beneath the ash. And that shows sort of normal life at the waterhole before the catastrophe. And so that's what we would consider an attritional assemblage. So all of the fossils that we see there are animals that were young or old or picked off by predators. They died normally, quote unquote, and then they were scavenged. Their bodies were exposed to the elements. We find very fragmented remains, and none of these animals were necessarily living together. This is spread over a longer period of time. And then above that, we have our disaster or ash layer, which of course is that ash that is infilling the water hole and preserving the really incredible fossils that we'll be talking about for most of this lecture. And then on top of that, we have what we call the recovery sands, which are alluvial or river sediments that were deposited after the eruption that show that the fauna returned to this area sometime after the catastrophe. So Ashfall was discovered back in 1971 by a guy named Mike Voorhees. Voorhees was a paleontologist and professor at the University of Nebraska in Lincoln. He's now retired, and he was out doing mapping and surveying work when he discovered the lower jaw of a juvenile rhinoceros starting to erode out of the hillside. And he took this photo down here. That is the original field photo from the very first discovery at Ashfall. And at the time when he found this and when he took this photo, he had no idea how important of a discovery he was about to make. But after he took this photo, he went ahead and did some more excavating around that jaw, and he found that the skull of that rhinoceros was complete. And so he collected that, and when he did, he could see bones continuing back into the hillside, which suggested to him that that individual was probably complete. And so he took a note of that, marked the location, and left that as is, and eventually, a few years later, he was able to return with a crew from the university, and they went to excavate that individual. And they excavated that specimen. They found that juvenile rhinoceros was remarkably complete and incredibly well preserved. And while they were excavating, they discovered evidence of mass mortality, that there were lots of other individuals that were similarly complete and well preserved nearby. And that's when they realized that this was going to be a super significant site. So shortly after that, they were able to get a whole bunch of money from the National Geographic Society in order to quarry out this area. And so in the summers of 1978 and 1979, they did their quarry, and they found and removed the skeletons of dozens of extremely complete examples of a wide variety of taxa. And they took those to the university to be prepared and studied. But while they were out here doing this excavation, the local townsfolk would come and watch. It was kind of became a spectacle to them. It would gather crowds of people that wanted to see the excavation and talk to the paleontologists while they were over here doing this. On the right there, that's a photo of Mike Voorhees himself excavating the skeleton of a barrel-bodied rhinoceros. And so while they were doing this excavation and talking to all these townsfolk, they realized that there was an opportunity here, not just for the site to be a dig site, but to actually make it a park and make it an opportunity for public education, which is how the idea for the state park was formed. And that came to fruition 20 years after the initial discovery in 1991. They opened as a state historical park with what they called the Rhino Barn. They built a structure over the dig site so that they could excavate these fossils and study them in situ, and so that people could come and see the excavations and talk to the paleontologists. And originally, the Rhino Barn was a very small, sort of open walled construction. And so eventually, they fully excavated all of the area that they had covered in that initial Rhino Barn. And they decided they wanted to expand to continue the operation. And so in 2009, the new Hubbard Rhino Barn opened its doors to the public. And you can kind of see the comparison. The top photo there is that small original Rhino Barn. And the bottom photo, that is the current Hubbard Rhino Barn. And I wonder if you can see, no, you can't. You guys might be able to make out a couple of dark squares kind of around here in the photo of the Hubbard Rhino Barn. Those are the footings of the original Rhino Barn. So the original one only covered kind of the little sliver at the end of that photo. The Hubbard Rhino Barn is, I believe, 8 times the size of the original. It was a huge expansion. So getting into the fauna of what we find at Ashfall, a few minutes ago, I mentioned something called a barrel-bodied rhinoceros. So what exactly is that? Our most common fossil here at Ashfall is Teleoceras major, which is that barrel-bodied rhinoceros. We find Teleoceras in all 3 of those layers I talked about. We find a lot of them. And the reason that it's referred to as a barrel-bodied rhinoceros is because this was a very short and extremely rotund rhino. An adult male Teleoceras would have been about 10 feet long from nose to tail and 10 feet around in circumference at the rib cage. So the I just think that's amazing. It's one of my favorite things to tell people that this animal really kind of would have looked like if you just took a barrel and stuck some stubby little legs on it. That's Teleoceras. And the other great thing about Teleoceras, other than the fact that it is just so comically proportioned, is that there are tons and tons of them at Ashfall. We have dozens and dozens of extremely complete skeletons of these guys. And since they're in that catastrophe layer, these animals all lived and died at the same time, which gives us a really rare opportunity to do some paleoecological studies. We've been able to learn things about the kind of social groupings that they had, the sex ratio in those social groups, and we've even been able to determine that they had seasonal calving. So you're probably wondering how we determine the sex of a rhino that's been dead for 12 million years. So in this photo, hopefully you can see it pretty well. We've got a couple of skulls here, pretty apparent of Teleoceras. This one over here on the left, and then this one down at the bottom right. Now, all of the Teleoceras have this tusk in the lower jaw that you see here. But notice this one on the lower right has a very large tusk. This is a male. And then on the left here, the much smaller tusk, this one is a female. So Teleoceras has a very distinct sexual dimorphism with those tusks, which allows us to very readily determine whether it's male or female. And because of that, we've noticed that the vast majority of the rhinos at Ashfall are female. So that suggests to us that they had a sort of matriarchal social grouping that would have been structured around the female and their young, and that maybe just a few dominant males would have been defending harems of a large number of females, which is not a behavior that's seen very often in modern rhinos. So this was kind of an unexpected discovery. Now, as for seasonal calving, we have quite a number of young rhinos that are found at Ashfall. This is the most famous example here on the left. We have an adult female rhino nicknamed Sandy next to a very young calf, which is nicknamed Justin. And since they're found in such close proximity, it's very likely that this was a mother and calf pair. And we have several likely mother and calf pairs at Ashfall. But all of the calves that we find with their mothers are very young. Based on the growth of the teeth, we estimate that these calves were probably a month or two old when they died. And the fact that we don't find any calves that are 6 or 8 months old suggests to us that they had a distinct calving season. They weren't reproducing year round, and that this eruption was right around calving season. And we actually even found one rhino that was pregnant. So in the original quarry, that was one of the ones that was found removed, and the pelvis is now on display at Ashfall, which is that picture on the right. And all the little bones that you see inside of the pelvis, those are the bones of the fetus. And so, like I mentioned, with the mother calf pair there that were nicknamed Sandy and Justin, most of the fossils at Ashfall have cute little nicknames. The rule is that whoever finds it, or particularly the skull, whoever finds the skull gets to give the animal a nickname. So there's lots of fun ones spread out throughout the barn. One of my favorites is this one here, which was a male and a female found right next to each other, and they're nicknamed Mulder and Scully, which some of you guys might get that reference. So I just think that's a fun one. And there is something important about these two. So we're going to talk about them a little later. We'll come back to it. Remember Mulder and Scully. So now those rhinos are not only the most common fossil that we find at Ashfall, but they're also usually the first. As we start to dig down in the ash, we usually find the rhinos in the uppermost levels of the ash. But if we start to dig down deeper below the level of the rhinos, we start to come across the fossils of horses. We have 5 different species of horses that are known from Ashfall. We have both tridactyl or 3-toed horses and monodactyl or single-toed horses. Let me see if I can move. I don't know if I can move the picture of me on there. But up in the top right there, partially covered, is a display that we have at the visitor center where we have the lower legs of all 5 of our species of horses next to the lower leg of a modern horse. And so we have a variety of heights of our horses. And some of them have very well-developed side toes, and some of them, the side toes are very reduced or even completely absent, which is more similar to a modern horse. So at Ashfall, we have a really interesting sort of snapshot of the evolution of horses captured. At this time, horses were doing really well in North America. There was a very wide diversity of different species of horses. Like we have 5 here that were living all in the same spot, and they were doing different things in the ecosystem, filling different niches, and showing different morphologies, some of which we would consider more primitive or more derived, as some of them were starting to move towards the niche more so of what we would think of as modern horses, and some of them were still succeeding in more of the ancestral kind of lifestyle. Now, all of our horses at Ashfall are still quite a bit smaller than a modern horse. So we have a picture down on the bottom here on the left. This is a skeleton of our largest species, Neohipparion, which was about the size of a mule deer when full grown, so still a lot smaller than a modern horse. And on the far right there, that is our smallest species, Pseudohipparion, and that one's more about the size of a small dog when it's full grown. It would come up about to my knee. Really adorable little horse to look at. And at the same level in the ash as those horses, we also find camels. There are 3 species of camels that are known from Ashfall. Only 2 of them we've found in the ash bed itself. Those would be Procamelus and Protolabus. Procamelus up top here is the ancestor of modern camels. And then Protolabus is a more primitive offshoot that didn't really go anywhere. And then only known from the waterhole sand is my favorite Apicamelus, or the giraffe camel. And as the name suggests, this was a camel that had a very elongated neck like a giraffe and was probably filling about the same role in the ecosystem. Kind of an interesting thing with Apicamelus is that it elongated its neck in a different way than giraffes do. So for giraffes, each one of the vertebrae in the neck is kind of equally lengthened. But Apicamelus, for some reason, kept some of its vertebrae still short and normal, and some of them really stretched out. So all of the lengthening happened in, I believe, about 4 of the vertebrae. So we also have several species of dogs, 5 species of dogs that are known from Ashfall. Our first one up here, Synarctus, is our small raccoon-like dog. It is the only carnivore that we found a mostly complete skeleton of in the ash. And the specimen is that picture there in the top right. It's a little bit covered, but you guys can see the vertebrae coming down there to the pelvis, and the back legs are folded up, and the foot. And if I can see the whole picture, it has actually the forelimb kind of in front of the face. He died in this sort of a pose, which is interesting. And the skeleton of this little raccoon-like dog is found right in between those 2 rhinos that I mentioned, Mulder and Scully. And so actually these bones that you can see in the top of the picture there, those are the toe bones of Mulder. This dog is right at Mulder's feet. And interestingly, the skeleton also has a lot of fractures, some evidence of a lot of pressure being applied to it. And so what appears to have happened is that the Synarctus would have died first, and he would have been probably already partially covered in the ash when Mulder and Scully walked in, and Mulder stepped on and broke some of the bones. So these are the kind of just incredible resolution, the details of these stories that we can piece together at Ashfall of the final moments of these animals. Our next species of dog, Leptoscion, is known only from really partial remains in the ash bed. We found 1 single forelimb, and that's it. But that's better than our other species, because our next 2 here, Alurdon and Epicyon, these are our bone-crushing dogs. These would have been scavengers. And we know they were present in Ashfall because we find their bones in the waterhole sand. But we haven't found any of their bones in the ash bed, at least so far. What we do find, however, is some trace evidence of them. We find their footprints. In that picture in the bottom right, if you look where the 2 black arrows are, it's a little hard to make out, but you might be able to see the gray sort of blobs there. Those are actually footprints from those bone-crushing dogs still preserved. And we also find evidence of them scavenging these carcasses of the other animals. So as these horses and camels and rhinos were dying, these bone-crushing dogs would have been routinely making trips to and from the waterhole to pull apart and scavenge those skeletons. And then our last species of dog here, Carpocyon, this was closely related to our bone crushers, but it was a smaller dog, and the teeth suggest that it had a much more omnivorous diet. It was eating a lot of plant material. So as far as the evidence that we see of the scavenging from those bone crushers, we see that on a lot of the skeletons at Ashfall. There's lots and lots of evidence of it, but I've taken pictures of a couple of really striking examples to show to you guys. So on the left here, if you can see where this red 4 is, this marks the skeleton of a juvenile rhinoceros. So these are the ribs on the left and right side, and then both of the hind limbs are here in place. But what we're missing, what should be here, is the spinal column and the pelvis. And we actually find them over here on this pedestal. So what appears to have happened is that after this rhino died, while the body was decomposing, one of those bone-crushing dogs grabbed a hold of the back end of it and literally ripped off the pelvic and spinal regions of that animal and dragged them several feet away to eat the meat and then just left the bones there. And then another example here on the right, this number 15. That is an adult male example of our small horse pseudohipparion. And this one's named Andrea. Andrea's in a really weird pose. The body's kind of contorted up. And already that immediately is kind of an indicator that the body was probably dragged around by scavengers as it was decomposing. But then if you look closer at this leg in the bottom right, this hind leg, if you look up close by the body here, you can look out that central hoof and the side toe that I was talking about. And then further away from the body is the femur, the upper leg bone. So that back leg was ripped out of socket and turned around and then dropped right next to the body. So if we continue to dig down deeper into the ash at levels below those horses and camels, we start to find saber-toothed deer or musk deer, which despite the name, these are not actually deer, they're a separate family. And it is in extant groups. These guys are still alive today in Asia. So we have a drawing that is the reconstruction of the Ashfall species. And I have that right next to a photograph of a modern musk deer. And down here is an example of a skeleton. So these guys are sexually dimorphic. The fangs, the saber teeth are only on the males. They use those for infighting. So this skeleton here is a female and does not have those fangs. But on the picture on the right there, you might be able to just make it out. That is our curator, Ash House, in the Ashfall collections, holding up one of those saber teeth. They're very small because these are just little animals. Now, the remains of these guys are often very disarticulated. Like you can see that this skeleton is kind of blown apart. And the reason for that, we think, has to do with them being so low down, is that these animals died earlier. And as the rhinos were walking into the waterhole, they were stepping on the dead bodies of these saber-toothed deer and breaking apart those skeletons. So we continue to dig down to the very lowest levels of the ash where it meets the waterhole sand. We start to find birds. There are 3 species of birds that are known to Ashfall. We only find them in the ash, which makes sense because birds generally don't fossilize very well. So Ashfall is one of those rare chances where we can get those birds fossilized because they were buried pretty rapidly in that volcanic ash in a very low oxygen environment, which allowed those very small, fragile bones that usually degrade to be preserved. So our most common species here is Balearica exigua, which is our crown crane. And it's actually the same genus as modern crown cranes that are alive today in Africa. So the photo on the top right, I took at the Omaha Zoo in Nebraska of an African crown crane that's alive. And then on the bottom is a fossil crown crane from Ashfall that probably would have looked very similar when it was alive. And you can see that's just a beautiful skeleton, very complete and articulated from the head down to the toes. And it even actually has impressions of the feathers preserved in the ash. Our other 2 species, we have a secretary bird mimic, which was a bird that had convergently evolved to look very similar to the African secretary birds that we know today. But this guy was actually much more closely related to hawks. And then our eagle-like scavenger, which was most closely related to vultures. At the same level as those birds, we also find a couple of species of turtles. We've got our musk turtle and painted turtle. And we've also found 1 species of giant tortoise in the genus Hesperotestudo. Since they only ever found one, it was nicknamed Lonesome George. And George, interestingly, wasn't found down at the bottom with the rest of the turtles, but he was actually found way up at the top, even above the rhinos. And we'll talk about that more in just a second. But then we also have 1 species of snake, which is still undescribed. They haven't published the study on it yet. But snakes are another one of those things that don't tend to preserve very well. Usually snake fossils are just isolated vertebrae, but we have an almost complete and pretty well articulated skeleton of our species of snake.
What's the snake's nickname?
It does not have one that I know of.
Okay.
So some other animals at Ashfall, we also have 1 proboscidean, which are relatives of elephants. It's called Eubelodon. We find lots and lots of fossils of Eubelodon in those waterhole and recovery sands, but we haven't found any evidence of it in the ash bed yet. So here's a reconstruction. And the bone here in this photo on the right is actually a partial pelvis from one of those Eubelodon that was eroding out of the waterhole sand outside of the rhino barn. We also have a couple species of large carnivores. Those are Barbarophilus, which is the false saber-toothed cat, and Ishiraioscion, which is the bear dog. which is kind of a misleading name because it's not related to bears or dogs. It's part of an extinct group. We know these guys from some very partial remains in that waterhole sand. This is sort of the holy grail at Ashfall, is to find an articulated skeleton of one of these guys in the ash bed. Everybody wants to find one of these guys. We've been looking for decades and so far have not found it, but you never know. So this whole time, as I've been going through these animals, I've been telling you guys about sort of the levels in the ash that we're finding each different species. And that shows us the sequence, the order in which they died. They died generally from smallest to largest, which makes sense. Because if you have larger animals, you've got bigger lungs, higher lung capacity. They're going to be able to survive inhaling that ash longer than the small animals. So at the very bottom, we saw those birds and turtles, very small, very susceptible to inhalation. They probably would have died very quickly within the first couple hours of the ash reaching this area. And then a little higher up, we have small mammals or musk deer. Higher up still, we've got the horses and camels getting a little bigger. The rhinos, bigger still, they're up on top. And then the giant tortoise way up there, Lonesome George. And the reason that Lonesome George probably survived so long is because giant tortoises have a very slow respiratory system. They don't intake a whole lot of air. So he would have been able to survive inhaling that ash for longer. And so then what happened to the other animals? Like those large carnivores, the eubelodon, why aren't we seeing their fossils here? Well, we know that those animals almost certainly survived longer than these guys. The eubelodon, it's a huge animal, big lungs, it would have been able to survive quite a while. And the carnivores, there's sort of a lifestyle thing going on there. If you think about our horses, camels, rhinos, these are all grazing mammals. So they eat vegetation that's on the ground that's covered in ash. So in order to feed, these guys were probably sticking their noses down into that ash and inhaling just enormous quantities of it. And the carnivores don't have that problem as much. And they also are more likely to shelter in their dens and burrows and get out of some of that ash that's in the air. So they would have survived longer. They still would have eventually died. Everything in this area died as a result of this eruption. But it seems that they went somewhere else. They didn't die actually in the water hole to be preserved. At least as far as we can tell. We're always hoping to find the exception to that rule every summer at Ashfall. And this is a photo I took in the ash bed, which shows the sequence really well. This cluster of little bones here in the center, that is the disarticulated skeleton of one of those little saber-toothed deer. And then on top of it, right here, this is a horse. And then even on top of that, there's the rhino. So you can see that sequence of little animals on the bottom, big animals on the top. So now if we want to figure out the time frame of what's going on here, how long was it after the initial eruption before these animals started dying? It's really hard to say for sure, but our best indicator is something that's called Marie's disease. So Marie's disease is this frothy abnormal bone growth that forms as a result of lung damage. We observe it today in medical and veterinary sciences, in humans, in horses and dogs, as a result of inhaling particles from fires or even diseases like lung cancer. Now we find this bone growth present on pretty much all of the large mammals at Ashfall. We find pretty mild cases of it on the horses and camels. So that suggested to us that they survived a couple weeks after the eruption, long enough for that lung damage to really kick in and start forming visible growths on the bones, but not much longer than that. However, in the rhinos, this growth is really severe. There was a lot of extra time for this growth to accumulate and to be more present on the bones. So that tells us that the rhinos survived even for weeks after the horses and camels had died. So the symptoms that we would expect to see of this disease would be, you'd see a lot of swelling in infected areas. There would obviously be a lot of pain involved for these animals, and they would start to exhibit fevers. And the fever may be the key to explaining why we have so many animals here in the water hole in this small area, especially for the rhinos, as they're suffering from the advanced stages of this disease and they've got these high fevers. They're going to the water hole and they're walking into the water and submerging themselves in the water to try and cool down in their final moments. And then they die there. And again, the wind is pushing that ash in, burying them and preserving them. So over here on the right, I've got a few pictures that I took in the ash bed to show you this Marie's disease. So on the top left here, this is the most common presentation. If you can see this sort of lumpy, almost popcorn texture on the toes of this rhino here. The bone growth usually presents in the extremities, especially on the fingers and toes, but it can be found anywhere on the body. So on the top right there, That rhino even actually had a little patch on the lower jaw at the end, just behind the tusk. And then on the bottom here, this rhino had a really, really severe case of it, covering all of the ribs and much of the scapula. You can see just all over the body. And so that's the thing that a lot of people don't realize about Ashfall, and a lot of people are surprised when they come and we explain this to them. It's often described as a Pompeii in the prairie, but this wasn't like Pompeii where these animals were instantly buried. This was a drawn out ordeal. We're talking about weeks or months of these animals inhaling this ash, damaging their lungs, forming this growth on their bones before they finally died. So today, excavations are continuing in the Hubbard Rhino Barn every summer. Ashfall serves as kind of a hub for mammal paleontology. Researchers come from all over to study the fossils at Ashfall, and visitors come from all over the country and even all over the world to see it and to talk to the paleontologists, which makes it an incredible place for public education. I talked to one family while I was there this summer that had come from Germany, and they said they read about Ashfall in a book, and it was like at the top of their list of like things to see in the United States was this place in the middle of nowhere, Nebraska. That is some dedication to go to Royal Nebraska from Germany. Now the excavations are mostly done by undergraduate interns as students, which also makes it a great location for the next generation of paleontologists to learn and to grow. And so to give you an idea of how well that's going, this photo on the left is one of the few photos in here that I didn't take. This is a little bit of an older photo. You'll see this in a lot of Ashfall's promotional material. They actually even sell a fridge magnet of this photo. And I have it in my house. My parents got it when mom came to visit. But the intern that you see in this photo here is none other than Samantha Wright, who I know very well because she's my boss. She is the one who runs that paleontology research lab in South Dakota. And she's the one who told me, Isaac, you need to apply to Ashfall. And a lot of you guys are also probably familiar with the John Day fossil beds out in more Eastern Oregon. The current director there, Nick Famosa, he gave a wonderful presentation for us this summer, and he also started his career in the Rhino Barn as an intern. So wanted to share with you guys a little bit of the work that I got to do over the past summer season. So on the right over there, that's a picture that I took of Katie and myself on our very first day starting to excavate in the Rhino Barn. And then here's a photo of Katie on our spot. So the way this worked was they sectioned off an area of ash and they said, this is your guys' spot. You're gonna stay in this little area all summer and you're gonna just slowly, carefully excavate down through the ash until you either find some fossils or until you run out of ash, until you hit that water hole sand. So this is what it looked like when we started, pretty nondescript. And you'll notice that Katie isn't wearing any shoes in this photo. And that's not weird, that's actually normal for Ashfall. We always go barefoot when we're working in a pit. And the reason for that is the ash isn't like solid rock, it's just ash. So it's just a fine powder that's compacted together. You can just scrape through it so easily. And so we don't want to wear shoes with treads and be kicking that ash up and causing unnecessary erosion to the ash. That's the main reason that we don't wear shoes. It's also nice because it's a little scary walking around in the pit because it's so rich with fossils. You're so scared you're going to step on something. And so being able to feel what you're stepping on to make sure that you it's not something you shouldn't be stepping on is nice. And then the third sort of benefit of being barefoot is that it is hot in Nebraska in the summer. And there's no air conditioning in the Rhino Barn. And the ash is pretty cool. It's kind of like sand is how it feels. So it's really nice to take off your socks and step down onto the cool ash on a hot day. So this is what our spot looked like towards the end of the summer. And all this tan stuff you can see here, that's that water hole sand. We dug through all the ash in those areas. We were not lucky enough to find any skeletons or any major bones, but we did find some interesting trace fossils. So over here on the left, we found this unidentified circular trace fossil of some kind. We don't know what it is exactly. We think that potentially it could be a footprint from one of those Eubelodon. And if that's true, then it would be the first one ever found in the ash, which would be super exciting. But that's not confirmed or anything. We don't know that. But what we did find was a set of the tracks from those bone crushing dogs, which is very rare and a super exciting find. Most of the time, they're incredibly faint. They're very hard to see. And so we had to look very carefully for them all summer, which did pay off. And I have a picture of one here for you guys. hopefully some of you can make it out at least. But if you look for the darker gray here, this is the path of the foot. And these are the toes, 1, 2, 3, and 4. They're so faint, so hard to see. So actually, when we take measurements of them to document them, we go in super early before the sun's come up, so there's no light coming in through the windows. And we take out a strong like lamp and set that at like a harsh angle from the side in order to cast shadows in those prints so that we can see them a little better. And even still, you're down on your hands and knees looking really close to make sure you're seeing them all. We also got to do some field work outside of the rhino barn, which was really exciting. So this picture right here on the left, this is a skull of a teleoceras of that barrel-bodied rhino that was eroding out of that waterfall sand. And it was starting to get damaged because it was exposed to the elements. So we went out there and we constructed a plaster field jacket to collect it. And this building in the background, that is the rhino barn. So you can see we really, ventured out in the wilderness to do our field work. And so we constructed that field jacket to get ready to collect it. We were able to flip it over and remove that fossil. And then we used the incredibly high-tech paleontology wheelbarrow to transport it up to the lab, where we could start preparing it. And so here are a couple of photos that I took in the process of preparing it from the underside, just starting to come out. This is the back of the skull and the front of the skull with a couple of the upper teeth here from the left maxilla. This is actually the palate, which was broken off and pushed forward. And then the other side of the jaw, of the upper jaw, was also broken off and pushed forward. So we cleaned that up as much as we could. I removed the bones that were broken off and moved so that they could be pieced back together and glued back onto the skull later. And then we flipped it back over so that we could continue to prepare it from the other side.
And what animal?
This is teleoceras. This is the barrel-bodied rhinoceros. And unfortunately, I don't have any photos of it completed. I thought I did. And when I was looking through my camera roll to make these slides, I could not find them. So you'll just have to trust me on that. But here's some other photos instead of some of the other lab work that we were doing. So here was all 3 of the interns in the preparation lab. And in the background behind Katie here, you can see some of the buckets of concentrate. We were sorting through those to find microfossils. And then on the right, there's our other intern, AJ, working on preparing the shell of a giant tortoise. And that's what I have for you guys today. So here's where I got all of my lovely photos from. And here are the sources that I used. And if you guys are interested in doing more research, trying to learn more about Ashfall, which I do highly recommend because it is so incredible. There's so much to learn. I tried to really pack a lot into this pretty short presentation, but we really only scratched the surface. There's a lot more to learn. And so if you guys are interested, please don't hesitate to send me an email, and I will be more than happy to send you all of my sources and more. And with that, I'll go ahead and open it up for questions.
Well, it sounds like the matrix there, the ash was really soft. I assume your preparation work is done with paintbrushes.
Yeah, so when we're excavating in the ash, we start with a trowel. That's our most aggressive tool, and we just very gently try and take off like a millimeter at a time. And then if you find something, you switch over to like a medical scalpel and some dental picks and a brush. That's how we were working the whole summer.
Harold Hines online here. Where did your fellow workers come from?
Oh, where did
What
somebody asked
what
online
schools are they
where the
from?
other interns came from?
You?
So Katie was from Minnesota and AJ traveled the farthest. He came all the way from West Virginia.
I was gonna say, you can tell how committed you are to the project, I'm saying we instead of they. We, 10 years ago.
Oh, somebody way back.
So you mentioned the geology of Ashfall.
Mhm.
It seems like the volcanic eruption is pretty large.
Mhm.
Everybody done in geology. So they're ready to look at where other lakes.
Right, that's the big question is like, if we found in one spot, shouldn't there be more? Because obviously there would have been a lot of water holes all over the country where this exact process was happening. However, trying to locate them is really hard because they don't have topographical maps from the Miocene. So we don't know where water holes would be. So there's a a huge amount of luck that goes into trying to find something like that.
Is that something that LiDAR would be helpful in looking?
No, unfortunately not. We've tried to do some imaging. We've even tried to use ground penetrating radar in the ash bed, but it's just not very effective because the fossils do not differ enough from the surrounding matrix in their density. So when they do the GPR, all they got was blips. They got like a little blip that like, that probably is where one of those teleoceras is, but they didn't see like anything else. And they couldn't get any kind of resolution of like, is this a complete skeleton? Are there bones? Just unfortunately didn't work.
First of all, make sure you repeat the question so that people know what the questions are. Secondly, James has a question. For the exposed fossils and the ones on the pedestals, are you guys putting consolidant on those?
Only if necessary.
But make sure you repeat it so James knows you're answering this question.
Yeah, so so James asked if we put consolidant on the exposed fossils, and the answer is sometimes, but only if we decide that it's necessary. Our goal here at Ashfall is really to disturb the fossils as little as possible. So we're only going to add consolidants or chemicals if we have something that's really fragile that is determined to need that kind of treatment.
Do you add any consolidant to the pedestal itself to keep it
Ooh.
from like slumping?
Oh, no. So the way that we dig through it, yeah, because the ash is so soft, it is a little tricky to make those pedestals. There's the risk of like them collapsing. And the way we do that is actually anytime we're excavating the ash, we actually wet it down first. We apply water, which helps kind of keep the ash together better. And so that's especially important when we're making those pedestals. And then once the ash dries out, it will have no problem retaining that shape.
Any DNA work?
So Greg asked if there's any DNA work. No, there's no original organic material preserved at Ashfall. Everything is permineralized, so there's no DNA left to be found.
Maybe not as sexy as bones, but are there, and because that's so soft, is there any areas where like insects or the flora has been preserved from that event?
Yeah, we do have some flora. Unfortunately, the plants don't seem to preserve very well. But we do have evidence of like reeds, kind of the types of plants that you would expect to find around the water hole. Although they're so poorly preserved, I don't think we can get like specific taxa on them. And I don't believe we have any actual insect fossils, but we do have some bioturbation, some like burrowing into the ash that is thought to be from insects around the time of the eruption. And we do actually have ant nests as well. I forgot about this. Yeah, that's an interesting. We have infilled like ant nests in the waterhole sand, which is interesting.
So you said that you had a bunch of the substrate that you were searching for microfossils in the buckets that the interns were doing. Sorry.
Yeah, no, it's all good. So somebody asked about the microfossil concentrate that I mentioned. That actually isn't from Ashfall, interestingly. So a lot of the lab work that we do isn't necessarily from specimens that are found at Ashfall, because everything we're finding, we're leaving in situ in the rhino barn. So in the lab, we work on fossils from all over the state of Nebraska. So the sediment that we were sorting for microfossils over the summer was actually from the site called KP121, which was the thesis site of Shane Tucker, who is our highway salvage paleontologist. So kind of as like a favor to him or his favor to us, either way you want to look at it, he sends us a whole bunch of sediment from that site and we sort through it and report back to him what we find.
So as you were describing this, I kept thinking about the Hot Springs Mammoth site. And that's in South Dakota. And it's similar but different. You've been to that one.
Yep, that one's
So
about.
how do they compare? And I'm not talking about necessarily the animals, because we know one's primarily mammoths or whatever. But how does it compare kind of in the overall generalities of it?
In
I mean,
generalities.
in your opinion, how do they compare?
Yeah, okay, so Aaron asked about the Hot Springs Mammoth site in South Dakota, which is a site I'm familiar with. I've been there quite a few times because it's about a little under an hour's drive from the school that I go to. So that is an interesting one. It's another one where you have building around a dig site, and we've got fossils preserved in situ. At the mammoth site, it's almost entirely of mammoths. Now, the process there is totally different, however, because at Ashfall, you have this volcanic eruption that created, a snapshot of time. And it's a really sort of not a particularly deep deposit. There's about, 8 to 12 feet of ash at Ashfall, and that's it. That's where we find the fossils. On the other hand, at the mammoth site in Hot Springs, what happened was there was a sinkhole that would be filled up with water, and these mammoths, especially young male mammoths that didn't seem to be too smart, would go into this sinkhole. And the sides would have been slick. They wouldn't have been able to climb out. And so these mammoths tired and drowned in the sinkhole. And over a very long period of time, mammoths that would die and sink down, and very slowly this sinkhole filled up. So their animals were not existing at the same time, like Ashfall, and they have a very deep deposit. They have, tens of thousands of years of time already exposed there. And they've done drilling that they think it could go down even like 60 feet down further than they've already excavated.
That's cool. It's so different but similar in what you see on the surface.
Yeah.
But when you dig into it, enough metaphor there. You really get to how different they are. It's very cool.
Yeah.
So Isaac, when you said, so I got to go there a few weeks ago with Rick, gave you the tour. He was the superintendent for what, 20 or 30 years?
30 years, yeah.
And it was like the day before they were closing. And he mentioned he was upset because they weren't wetting things down enough.
Oh, really? Well, I had been gone for a couple of months. So,
But they were shutting down, so hardly anybody was there. So it wasn't, but it was kind of funny. He wasn't real upset. He just said, shouldn't be this way. You should be wetting this down. Because he was telling me about the pedestals and keeping the pedestals, stuff like that.
Yeah.
So it's kind of funny. So this person I'm talking about was at the ant meeting. In Warden.
Yeah, somebody.
So it seems like you have some fairly well preserved that have, bridge structures and things like that. You ever find organs or any sign of organs or internal body parts?
Generally, no, the soft tissue is going to degrade away. But we do actually have a few cases where we start to get a little bit, not like full on organs or anything, but we have, of course, the feather impressions in the birds. I've even seen, we have one specimen of that crown crane that has some of the cartilage from the trachea preserved. And I've heard that there was one of those saber-toothed deer found that had sort of some casting around it that was thought to be infill of the soft tissue of like the skin and the fur, but that was, pretty much impossible to preserve.
Why are you stopping when the ash stops?
Oh, yeah.
Lack of fossils.
Well, so all of the like extraordinarily well-preserved fossils are going to be in the ash in the water hole, right? And of course, the sediments below it, that water hole sand, those do have lots and lots of fossils in them, but they're not the extraordinarily well-preserved ones here. And also, we can sample those elsewhere. Like you saw the ones that we collected outside of the rhino barn. So when we want to find those water hole sand fossils, we go elsewhere. And the goal at Ashfall is eventually to excavate all of the ash and leave all of the fossils in place so that we have the water hole sand there. That's literally the bottom of the water hole. So you have the water hole totally preserved and you can see it, see the depression, and there are areas where you can see like the slope of it, the topography of the water hole, and like literally where these animals would have walked. So that's the goal there, is to try and preserve the water hole as it was 12 million years ago.
Judging on what you did this summer, how much can you estimate is left in terms of how many years worth of work before the barn is up?
Ooh, we think that we've got about 10 to 20 years left in the Hubbard Rhino barn. And then there's still more of the deposit. The water holes believed to continue. So it would be possible after the Hubbard Rhino barn is fully excavated to continue to expand to an even bigger facility and just keep going.
You build another barn.
Yep.
My next question is, for those of us who are living vicariously through you. Are you going back to Ashfall next summer, or do you have another step to take in what you're gonna do, for your extracurricular studies and work outside of your classes?
Yeah, it's, I'm a little bit undecided right now. There's a very good chance that I'll go back to Ashfall. I had a really great time there. I also feel a little skunked. I'm like, I wanna find a skeleton now. I'm like, I don't wanna give up. So yeah, I think that there's a pretty good chance that I'll go back, but we'll have to wait to hear back from everybody and decide.
Did you walk some of the stream beds and the gullies in the area?
We did, yeah, and we found some, modern bones and some Pleistocene fossils and even a couple of Miocene. Yeah.
So when you do that in the streams and outside of this actual, we'll call it a monument, but the park, are the material that you're collecting going to the university, or do you get to keep some of it?
We can keep some of it, if it's collected on private land. I don't know exactly what Nebraska's laws are on public land, but at least on private land. And so sort of the neighbor to Ashfall, the rancher who owns the next plot over, he's pretty friendly with the people at Ashfall. And so he lets the interns go and walk the creeks on his property, and whatever you find there is fair game. It's nothing monumentally important that the museums would want it, at least anything that we found. If we started to find like a proboscidean like skull eroding out of the gully, obviously Shane would try and take that from us.
But you got a little stash started?
A little bit, yeah.
That's where I'm living right here. All right, nice job.
Yeah.
All right, any other questions online? You might ask them.
Yeah, do you guys have?
I have
Go
Harold
ahead.
Hines here. I have a observation and a question. I wonder to what extent you have looked at Theodore Brown's book on the Mascall Formation here in Oregon. It would be a very interesting comparison between the area that you're working in and what they discovered there. Theodore Downs is the author, DOWNS, Theodore. Published a monograph on the Mascall information and Miocene information in Eastern Oregon here.
Yeah, I'm not familiar with that. That would be something that I would
Check it out.
So for the people in the audience who couldn't hear that question, he was asking about the correlation between Ashfall and the Mascall Formation in John Day. It'd be interesting to ask Nick what he thought about that, but also Dave, isn't that, there you are. The area where we were looking, that was Mascall, right? So how the stuff that we saw compared to what they're collecting, it'd be interesting to see if there's a correlation with that. Yeah. Yeah, but you might let him know it, checking with Nick. You can email Nick and you might have some.
Yeah.
Nick Formosa.
Yeah, Nick Formosa would definitely be the best person to ask about that. Seeing the hand in the back.
Hey, so I'm looking at the picture here of the dig, and it looks like on the right-hand side, is probably yet undug. It looks like you've done trenches through that, to see if there's anything, and then, you kind of come over to the edge, and there are different pieces that are excavated, and pieces that are not. Could you talk a little bit about how you decide to approach something like this, and where you decide to dig, and how the site develops?
Yeah, so somebody asked about the photo up here on the screen and what we're seeing with the trenches and the sort of grid pattern here. So yeah, like you mentioned, you can see kind of where I am. That's the area that we're currently working on. And then to the right, that stuff is mostly, unworked. And so we're generally like sweeping in that direction. We started way over here off screen, and we're sort of slowly working our way towards the other wall of the barn. And those trenches in a grid, they're like a 10 by 10 grid. And that's just sort of a pretty standard way of kind of doing it, of trying to figure out where you want to dig, where promising areas. So for Ashfall, we dig those trenches by hand carefully. And what they're looking for when they dig those, you want to see how deep the ash is, because you know you're only going to find fossils in areas where you have deep deposits of the ash. And then also, how often are you actually running into fossils? And that tells us whether or not an area is still in the water hole, or how, productive of a deposit we might expect to find in any one given area without us having to excavate like the whole thing to do it. And so those trenches, the whole site was originally laid out, but like that, and that's how they've decided where to put both of the barns. So the little section that was the original rhino barn was just really thick. There were a ton of skeletons right there. And they could see that when they were digging the trenches, they were running into bones all the time. And so like, okay, here's a really thick cluster of skeletons. This is where we're putting our barn.
Total size of the barn.
The total size of the barn, I could not tell you off the top of my head. It is big though.
Actually, isn't there online a picture of when the National Geographic did all the main, the trenching, that huge square area that they've got
Yeah,
before the barn was built?
yeah. Yeah, there should be a photo of the original quarrying, trenching somewhere. I wish I had had the foresight. I actually have a copy of the National Geographic that was published about Ashfall originally from the quarry. I wish I had brought it for show and tell so you guys could see it, but it's still out in South Dakota.
How long ago was that original?
The original one that was in 1978 and 1979.
The National Geographic.
Yeah. Yeah.
One more question about the Sentinel. There are a couple of things you might see what looks like the shape of a car in the upper right there. And then there's a box there that's excavated around it, but that
Okay.
box on the left is just yeah, there's the car.
Oh. Okay, we see it. It looks like
And then if you come on the left by the door there, there's a rectangular area.
It's like a coffin.
Yeah, like what causes that to happen? Why wouldn't you just develop that area with everything around it?
So when you see these pedestals, somebody's asking about kind of the topography of what's going on in the area that you can see in this photo. Any of the ash that's left in like a higher area, that's for a reason generally. So like this pedestal here, the reason that we keep pedestals that are really tall, like this one here and this one over here, is actually because we're seeing sedimentological features in the cross section that are worth studying. So this isn't a paleontology thing so much here as this is a geology. We can see flame structures, which if you guys know, that's like fluid escaping through like layers. So we have really distinct laminae in the ash. And so we've got all kinds of sort of sedimentological features that are visible in cross sections. And so we leave a couple of pedestals tall that have, good displays of those features in cross section so that we can study them. And there's even an idea that they've been starting to work on where, because we have these distinct laminae throughout the ash, and some of the layers are very distinctive, they're thicker, thinner. They want to try and correlate all these little like millimeter to half an inch thick layers of the ash and treat the fossil bed like a huge basin and get this like full stratigraphy at the micro level. Yeah, so that's why these ones are tall. But then for some of the other things you're seeing, there's a bone on top of this pedestal. All of these little pedestals, they have bones on them. This one has one of those reeds, one of those plants. There's a horse on this one. So everything that's left kind of strangely, like up there, it's for a reason. There's something on there that we're trying to preserve.
Last questions? Fantastic. One last day. A long way. So, try the lights.
Well, through both.
Yeah, so I suppose if there was a quarry on the East Coast where they.
I don't know what I did.
I don't know either. Screen sharing is stopped. I don't know. This is.
Make sure everybody designs in.
Yeah, so we'll go ahead and take a 5-minute break. We'll do our meeting at 8:30. Everybody's welcome to stick around for the meeting. We'll make it pretty quick, about 25 minutes. But I want to give everybody a chance to talk before they have to leave. 6 minutes, and I got to figure out what happened online.
First, it's mentioned to me that we get orders for this book.
Yeah, we have one person. We need one copy of the book. Dan said he has two of them.
Okay.
I just need to get it mailed off.
No, I need to send an email to Gary, see if he's still alive, and if he's got copies of it. Then I'll buy 10 or 12 of them.
If he has more of them left, we can keep.
You'll
doing it.
probably donate them, but I'll buy 10.
We were gonna take them off the website because we haven't had them for a while and they're just buried in house. So, but yeah,
That is our, our own publication.
Yeah,
We should leave it.
yeah, I think we should if we have some.
And you got enough new memories.
Nico said that if we had extra copies, that he would handle the processing if anybody.
Okay.
And we're gonna update the website so we can put on materials. We're gonna.
I'll get a hold of Gary. Well, I'll probably, if I can get a dozen, I'll buy that.
No, that'd be great. That'd be great. We lost you guys on the screen, but I presume you can still hear us and everything, so. I'm not sure what happened to our.
I can kind of hear you.
But we're gonna take a 5-minute break, to let the people who are here as guests move along. I'm gonna stop the recording.